go over what are covalent compounds, some of their properties, as well as how to name them. So like always, you're definitely going to need a periodic table for these notes. And that's really it for covalent compounds. So let's jump in and get started. So in covalent compounds, what happens is that neither compound is truly electronegative enough to be able to like fully steal the electron away. So this would be in our tug of war match where it's like pretty evenly matched. Maybe one is slightly more slightly stronger than the other one, but it's pretty evenly matched. So no one's able to like fully win that tug of war match. So that's what's going on in a covalent compound, is that they're either like super evenly matched, so the electron is really right in the middle, or they're unevenly matched, but not enough to where one can win, if that makes sense. So electrons, instead of being taken, they are shared. This typically happens between two or more nonmetals. All right, so it does happen between two or more nonmetals, because we'll find out that sometimes it can be between a metal and a nonmetal, but we will talk about that later in the year. All right, so covalent compounds have certain properties. So they are made of individual molecule units. So where in ionic compounds we have cations and anions, and they're made up of those. Covalent compounds are one big unit rather than those cations and those anions. Their solubility in water depends on their polarity. So if it's polar, it's going to be soluble in water. If it's nonpolar, it's going to be insoluble in water. They have really low melting and boiling points. Their melting points are generally less than 300 degrees Celsius. The bonds themselves are strong, but the attractions between your molecules are going to be weaker than the attractions between your ionic compounds. And molecular compounds can be found in all three states at room temperatures. So you can have solids, you can have liquids, and you can have gases at room temperatures. All right. So naming covalent compounds is pretty easy. So we are going to use prefixes to distinguish the number of elements used in covalent compounds. You do need to memorize all of these prefixes. So mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. All right, so our name would be prefix, name of your element, prefix, name of your second element, and then change the ending to IDE, so IDE. All right, the only exception is that under our new rules, we no longer need to use the prefix mono for either element, but it's never been used before for the first element. So we no longer need to use the prefix mono. So 1 is just assumed. It's never been used for the first element before, but now they're saying you don't need to use it for either one. But you'll still see it both ways. Sometimes you'll see it without the prefix, sometimes you'll see it with the prefix. So we want to make sure that you guys knew that mono is sometimes still used, so we still want you to know it, but that it doesn't have to be used anymore. All right, so let's jump into these. So it's pretty simple. So our first one is carbon disulfide. So our first symbol is for carbon, and carbon is a C. There's no prefix in front of that carbon. So since there's no prefix, we can assume that it's 1. So we're going to have 1 next to our carbon. Don't need to put 1s because they are assumed. And then we have disulfide. So that would be S. We have di, so that is 2. All right, guys. One important thing I want you guys to write down, and this is one of the biggest things that people miss with covalent compounds, is that we do not swap, drop, and reduce with covalent compounds. The prefixes are for those elements that they're in front of. You don't swap, drop, and reduce. You just write write the name exactly how it appears on the paper. Okay? So for our next one, we have sulfur trioxide. So sulfur is S. There's no prefix there, so we assume it's 1. 1s don't need to be written. And then we have trioxide. So oxide would be oxygen, and tri tells me that it is 3. So our formula for sulfur trioxide is SO3. Next, we have diphosphorus trioxide. So diphosphorus, phosphorus is P, and we have that di there. So di is the prefix for 2. And then we have trioxide, so oxide would be oxygen. And we have that tri prefix there, so that would be 3. So P2O3 would be our formula. Next, we have carbon tetrachloride. So carbon is C. Once again, no prefix, so that would be a 1. And then we have tetrachloride. So chloride is going to be Cl, and tetra is 4. So our formula would be CCl4. Last one of these, dinitrogen pentoxide. So dinitrogen would be N2, and then pentoxide O5. N2O5. Di is 2 and pent is 5. Okay, that's it for writing their formulas. So let's go ahead and try to name some of them. All right, so this first one, we have IBR. All right, so our first element is iodine. It does not have a subscript next to it, so it means it's 1, so it doesn't need a prefix. And then we have bromine. All right, once again, it doesn't have a subscript, so it doesn't have a prefix. So our name would be iodine bromide for that compound. You may also see it as iodine monobromide. Either name, you can see it either way, but you should never have the mono prefix on your first element, and you may only occasionally see it on the second one. Either name would be correct. However, this follows, the iodine bromide follows the more current naming rules. Okay, now then we have S4N2. Okay, so we have 4, so that gives us the prefix of tetra. And our element is S, so that's sulfur. So we have tetra sulfur. And then we have 2 nitrogens there. So di, and it's nitrogen, change the ending to IDE. So tetrasulfur dinitride. P3O8. So we have 3 for our first element. So that gives us the prefix of tri, and it's phosphorus. So triphosphorus. And then we have our oxygen, and that one has a prefix of octa, and then oxygen, so octa oxide. Now, guys, sometimes when we have 2 vowels next together, like this A and this O right here, what we would actually write this as instead of octa oxide is we might just write it, we would drop our A and write it as oct oxide. Again, either way is fine, but when we have 2, like an A and an O next to each other, we often drop the A. All right, next one, we have carbon and sulfur. We have a 2 next to our carbons. That gives us the prefix of di. And then C would be carbon, so dicarbon. And then we have a 6 next to our sulfur. Hexa, change the ending to ide, so hexasulfide. And last one, N2H4. So the 2 right there gives us di. And then our element for N is nitrogen, so dinitrogen. And then next to our hydrogen, we have tetra. And then it's hydrogen, so change your ending to IDE, tetrahydride. Okay, that's how we name covalent compounds. It's pretty simple since we use the prefixes. Big thing to remember is that you do not need to swap, drop, reduce. The prefix that is in front of that element is the number that goes with that element. Hopefully this was helpful. If you have any questions or you're confused at all, feel free to reach out to myself or Mr. Oglesby, and we'll be happy to help you. All right, guys. Have a good day. Bye.